was like, I've done it before, not a good idea. I warned you, man. I warned you.
All right, let's get out our notes. Page 13. Make sure we all have a calculator today. We're definitely going to need it. Good to go. Page 13. I believe we left off with parallel and perpendicular. Is that right? We're good to go? We finished that one? Okay. Today's going to be a calculator day. We're going to go ahead and move down to what's called regression. Maybe some of you have heard of this before. I definitely know you did this in Algebra 1. Again, that might seem like a lifetime ago. But what you did in Algebra 1 was probably by hand. Okay, regression. If I say line of best fit, does that kind of ring a bell? Okay, that's regression. Regression is just a shorter word to represent line of best fit. I'm gonna show you how to use your calculator today to figure out a regression or a line, sometimes a curve of best fit. Okay, so in this data table, regression is highly usable in statistics. So for those of you that might go into that next year with Mr. McGrady or at a college level, you're going to use regression a lot. It's a way that we can collect real-life data, but then use math to analyze it, like predict information, what might happen if this happens or if something else happens. So regression is very applicable to the real-world kind of statistics and data collecting. So in this example, we have different types of sandwiches, and we are comparing their total fat in grams to their calories. So what we're going to do is on our calculator, we're going to type in this data. So your calculator has that information. And just like we did with all of our other calculator steps, I'm going to write down the buttons that you need to press. So it might not be a bad idea to make sure that you write them down as well. Okay, so the first thing we're going to do is I'm going to show you how to type in your data. I want you to hit the Stat button. Okay, we'll do this in a little bit. Just let's make sure that we have these buttons or notes down. Okay, we're going to hit the Stat button and then Enter. Ready to go on our calculator? We're actually going to do this. Okay, so turn on your calculator. The Stat button is right next to the arrow keys, right underneath Delete or DEL. Okay, and I want you to hit Enter. By hitting Enter, you are selecting that Edit option because it's already highlighted. So I want you to hit Enter. Now, if you have numbers in your calculator, which you might because we did this during first period, I want you to use the arrow key to go up to L1 or L2 and hit the Clear button and then arrow back down. That should get rid of all the numbers. Okay, you can use the arrow keys to do the same thing for L1. I do not, when you do that process, I don't want you to hit delete, okay, the DEL, because the delete is literally going to delete that column, meaning you might go from L1 to L3, like your calculator would get rid of L2, literally delete it. It's not the end of the world if that happens because I can change it, but it would just save some time if you didn't do that. Okay, so just use the Clear button. So in L1, we're going to go ahead and type in the total fat grams. Okay, we're going to let that kind of represent our X information. And then in L2, we'll type in the calories to represent the Y information. So we can type in 9 and then hit Enter. And then 13, Enter. Keep typing in all of your data. Once you get done typing all of your numbers in L1, you can use the arrow key to move over to L2 and then type in the calorie values. when you get done typing, make sure that you have the same amount of numbers in each column. Okay, notice how 5 and 300 match up just like they do in the table. If you have more or less in the two columns, you're going to get an error message eventually, and we're going to have to go back and check that. Okay, so make sure everything is as it should be. So far, so good? Data in? Okay. What we're going to let the calculator do is graph these data points. Do you remember what it's called when you have a graph of individual dots all over the place? Yeah? A scatter plot. Okay, so let's go ahead and take note of this. To graph scatter plot, we're going to hit the blue second button, and then the y equals button, and then we're going to make sure the plot is on. Okay, again, we'll write down the kind of steps, but then we'll actually do it. Ready to go? Okay, so blue second button, and then the y equals. Notice how above the y equals it says stat plot. Okay, that's the menu that we're going to go to. And your plot 1, we want it to be on. Okay, some of yours might already say that, which is fine. If it says off, we're going to hit enter. And this is kind of a menu where you can select different things that you might want to see on your graph. First of all, we're going to select on. This is also letting the calculator know that the x's you want are in L1, the y's you want are in L2, okay, which everything's checking out. You also are able to choose different types of graphs that you want to see. For instance, notice how the dots are already selected, so that's going to give us a scatter plot. This calculator is able to do bar graphs, and it's also able to do those box and whisker plots that you might remember from Algebra 1. Okay, but we're just going to use the scatter plot option in this course. Okay, if you want to play around with these other ones, you can later. Okay. Now, in order for the calculator to graph these data points, just like any other graph we want to see, we have to hit the window button and make sure that we see what we want to see. Okay. What's the lowest x value that we have? 5. Okay, based off of our table, that was 5. Now, just to make sure that we can see this data point at 5 that the calculator is going to put on our screen, let's go a little bit lower than that. So for instance, maybe we can just do 0. What's the highest x value? 31. Okay, let's go a little higher than that. Just make sure we can see it. Oh, is it 34? Okay, we'll go a little higher than that. We'll go 40. What do you want to count by? We're going from 0 to 40. 5s? Deal. Okay, let's take a look at the y's. What's the lowest y value? 260. We'll go a little lower than that, maybe 240. What's the highest y value? 590. We'll go a little higher than that, maybe 610. And from 240 to 610, what do you want to count by? 10s, 20s, 30s, whatever you want. I think 20s might be a good idea. Okay, so let's go and add maybe one more step to this. To graph scatter plot, we hit the second button, then the y equals, we made sure the stat plot was on, and then we'll say set window. That way we can actually see it. Okay? Now, because we were using these in the last class, I need everyone to do me a favor real quick. Can you just hit the y equals button? And if you have anything in there, just clear it out. Okay, I don't want to graph an equation, I just want to graph the data points. Okay? Let's hit graph. Do we all have the same points? They're showing up?
Make a lot of noises when they just make a lot of noises.
We all good? All right, so by looking at these data points, what kind of graph do you think we should draw so that we can get as close to as many of those points as we can? Do you think a straight line would work? Do we have to curve it? Do we have to squiggle it? Straight line, I'd say that's pretty good, right? Well, you can't see it because the pen's pretty thick, but straight line, right? Okay, so what we're going to do now is let the calculator figure out the exact equation of the best straight line that would get as close as it can to all those data points. Okay, so next one, to find equation. We're going to go back to that stat button, but then we're going to scroll over to calc. We're going to choose the regression type. Okay, we're going to choose the type of equation we want, and then we'll simply hit enter. We ready to do it? Okay, so hit the stat button. This time we're going to scroll over to calc. By the way, when I write these steps down, whenever I box something, that means it's a button that you have to press. I don't know if you realize that or not. Okay, if I box something, it's a button. So we scroll over to calc. Now take a look at this. Starting with option 4, it says lin reg. Okay, and ax plus b, that's very similar to mx plus b that we talked about yesterday, right? So lin reg stands for linear regression, but you have other options. Quad reg is quadratic, like a U shape. You have cubic regression, that kind of looks like an S graph. Quartic regression, okay, like a power of 4. If we keep going, there's a different linear regression, but the equation's slightly different. We're not going to use that one, okay? You could do natural log regression, you could do exponential regression, you can do power regression, logistic regression, sine regression, like a trig function, okay? There you have many options. You just need to pick the one that you think is the best. And the way we know that is by looking at the scatter plot, okay? What shape do those dots look like? So we said it looked like a line, right? To best fit those data points. So let's go ahead and select option 4. Okay, for this example, a line makes sense. So we're going to choose linear regression. Again, your calculator just wants to confirm that the x's are in L1 and the y's are in L2. Okay, we're good to go there. So we'll just keep hitting enter down to calculate. And your calculator should eventually give you the equation with some values. Do your values match mine?
Yes.
We all have the same data, so we all should have the same numbers. Does that work out? Okay, so this screen is giving you two things. It's giving you the general form of the equation, okay, ax plus b, and then the calculator also gives you the value of those coefficients. In this case, what the A number is and what the B number is. Okay, so what I want you to do on your paper, we're going to write down this equation to 3 decimal spots. Let's do that down here. We had y equals, our A value was 11.731. Then we have an X, and then we got to add the B value, 193.852. According to your calculator, this is the best line that you could possibly draw to get as close to as many of those points as you can. Okay? Let's see how good this is. Okay, so back on our calculator, we're going to graph this line. Okay, it's going to graph it on top of the scatter plot so we can see both of them. Let's go to the y equals, and I want you to type in the equation you just wrote down on your paper. So 11.731x plus 193.852. And then you can hit graph. That's pretty close, right? Not too bad? Okay. Do you guys see how I think the very top point was filled in? Can you see that on your calculator? So the line is actually going through that data point. Okay, that's an exact value, but all these other ones are slightly off. Okay, so what this equation gives us is a way for us to predict information. Now clearly this line is not exactly perfect because it only goes through one data point. So it may or may not be a good predictor of future values or future information. But it's the best line that we have, so it's going to give us the best approximation. Does that make sense to us? This is the best one that works. Okay, so let's go ahead and use this equation to help us predict some information. The first question says, predict the calories of a grilled cheese burger. It's an interesting sandwich that has 97 grams of fat. Now that we have the best equation possible, how could we figure out the predicted calorie count? What do you think, Matt? Yep.
79 in for X.
All right, we're going to plug 79 in for X and see what we get. All right, go ahead and do that on your calculator. To exit out of your graph, hit clear a few times, and you can go ahead and type it in. We're going to plug in 79 for X.
That's healthy. Eat it 3 times a day for
What's our caloric count? 1,102? Is it 2? 20. 20, sorry. 1,120.601 calories. You might be able to have 1.5, maybe one of those sandwiches, and that'd be your meal for the day. It's a lot. No, thank you. We're good? Okay. Are we good so far? Okay. Let's check out the next one. Predict the fat grams of an 800 calorie sandwich. How can we use our best equation to help us predict that data? What do you think, Blair? 800 in for Y. All right. Now there's only one X in our equation because we chose linear, which means you should be able to solve this one by hand. Okay, you might not have to graph it and find an intersection like we've talked about previously. Okay, so go ahead and solve for X. We'll figure out our fat grams. Any takers? It's our fat. Go, Carter.
51.7.
51.7, or say it again? Is it 7.6? Okay. Or is it 6.7?
I got 6.7.
It might be a little off depending on how you round, like depending if you used all these decimals or not. But it's 51 point something, right?
Yeah.
Regardless? Okay. So again, this is an estimation. This is a prediction. Your numbers might be slightly different depending on how you round versus your neighbor. Okay, but I think 51.6, 51.7, somewhere in there should be great. Okay, grams of fat. How are we doing so far? Good? Okay, just to make it clear, again, these values are estimations because this line that our calculator gave us did not go through every single data point. So these numbers are a little off. Okay, a 79 gram fat sandwich may be close to 1,100 calories, okay, but not perhaps exactly 1,120. Okay, these are estimations. These are predictions. Okay, let's go ahead and try another one. We're going to flip to the back. The table below lists the number of Americans in thousands who are expected to be over 100 years old for selected years. All right. Number 1, find a friendly window to view the scatter plot. All right, let's see if we can get a scatter plot on our calculator. First thing, we got to type in the data. Okay, the calculator needs to know our information. So where do we go for that? Our buttons, our muscle memory come in, hopefully. We go to Stat and Enter. We're going to clear out the previous values. So go to the very top, L1, L2, hit Clear. Let me ask you this, okay, before we get typing happy, okay? If you were to type in 1994 into L1, what does that mean for your calculator, or how does your calculator read that number? Yes? 1,994. To us, that number is a date, but your calculator has no sense of time, okay, because it doesn't have a human brain. So to your calculator, this means 1,994. That's a fairly large number, isn't it? Can we perhaps make it a little bit easier for our calculator? Instead of starting with 1994, is there a smaller value that we could type in? Yeah? 94, okay, because normally we chunk a year or short or kind of a nickname instead of 1994. Sometimes we say 94. That's definitely smaller. We could do that. Can we get even smaller though? Yeah? Year one. Let's do year 0. The beginning amount. Okay? So remember the y-intercept at time 0 before you even start anything. That's how much you have. Right? We talked about that concept. Let's let 1994 be year 0. Okay, the starting year that we began this data. So we're going to let 1994 represent year 0. So then what would we type in to represent 1996? 2, right? 2 years after our starting date. So we're going to have 0, 2, then 4, 6, 8, 10. Those are a lot easier numbers for your calculator to work with. Let's go ahead and Y2 and we'll type in the other data. I don't think we'll have to change those. Those are fairly easily to work with. All right. So in order for us to see this scatter plot, let's go ahead to the window button. This is what number 1's asking us to do anyway, find a friendly window. What do you think the lowest x value should be? We typed in 0, right? let's go a little bit lower. I know it doesn't quite make sense because we're not going to go back in time, but let's just go a little bit lower so that we can see it on the calculator screen. Maybe we'll go -2. Our highest x value is 10. Let's go a little higher so we can actually see the data point. Maybe we'll go to 12. And what do you want to count by? Ones, twos, doesn't matter. Let's do the same thing for the y's. Lowest y is 50. Go a little bit lower, maybe 45. Highest y is 110. Go a little higher, maybe 120. What do you want to count by? 45 to 120. Want to do 5s? 10s? Doesn't matter. Maybe we'll do 10s. Okay? So the moment we hit graph, we should be able to see 1, 2, 3, 4, 5, 6 data points. If we can see 6 data points, this window is perfect. Okay? Let's go ahead and hit graph. 1, 2, 3, 4, 5, 6. Pretty good, right?
Yes.
All right. So on our paper for number 1, I want you to copy down the window that we typed in. X min, X max, X scale, same thing for the y's. Bless you. All right, X min, I think we said -2, max was 12, scale was 2, and then 45, 120, and we counted by 10s. This is kind of one of those multiple answer type questions. Your window might be different than someone else's, but as long as you can see all those data points, your window is good. So I'm not saying that there's one perfect window that everyone has to use to make it work. Okay, as long as you can see what you need to see, we're on the right track. Okay, let's check out 2. Determine the function that best represents your data. All right, take a look at your scatter plot. What kind of graph or shape do you think we could draw that would get as close to as many of those points as we can? Yes? Say it again? Exponential. Ooh, have we heard of that before? Exponential? We're going to do a lot with that this year, okay? Not to, that might work. No, that would work because exponential growth grows really, really quickly, right? Doesn't that kind of look like this graph? A little bit? You're going to be ahead of the game. We're going to do that later this year. But I think there's a more simpler model that we could use that more of us are probably familiar with. Okay, but that's definitely an option. You could try that. Is there another type of graph that might fit those data points? Yes? We could do a quadratic, right? Doesn't that look like one side of a parabola? Right? Okay, so I think we're more familiar with parabolas than exponentials. Is that a fair assessment? Okay, let's try that. All right, so determine the function that best represents your data. Quadratic, because, what do you want to say is a justification? Because a curve fits better than a line? Yeah, simple guys, simple. Okay, simple words. Quadratic because a curve fits the data better than a line. All right, now that we know which model or equation would be best, okay, we're going to let the calculator find that for us. All right, so back to the calculator. We're going to hit Stat, scroll over to Calc, And if we said a parabola or a quadratic equation would be best, which option should we pick? 5, quad reg, right? Okay, select quadratic regression. It's just going to confirm with you that your x's are in L1 and your y's are in L2. So we can scroll down to calculate and hit enter. So your calculator at the very top gives you the equation setup and then the A, B, and now C value that we're going to plug in to those coefficient spots. Okay, so to 3 decimal places, we're going to write down the equation. Y equals 0.402 x squared plus 2.039x plus 50.071. That's the best quadratic curve that could fit those data points. Let's actually see how close it gets. Okay, let's let the calculator do the work. Can we hit equal button or y equals? Let's clear out the line from the previous example and we'll type in the function that we just wrote down on our paper. That's pretty good, isn't it? That's a lot closer than the line, right? From the last example. So that means when we use this equation to predict any data, the actual solutions we get are going to be really good ones, like really, really close to the real life data, if we have that available. So this equation is a very good predictor or estimator. Okay, so that's really good so far. Let's check out 4. Speaking of predicting, let's make some. Predict the number of 100-year-old Americans in 2010. How can we use this equation that we let the calculator find for us to predict that data? What do you think, Blair?
Put 16 in.
Why 16? Yeah.
That'd be the year that you kept going.
If you kept going. Okay, remember, a little tricky, the data table actually gave us the year amount, but what we typed into our calculator were smaller values. Okay, so we have to kind of figure out which smaller value would correlate to 2010. That's 16 years after 1994. So into your equation, okay, using your calculator, I want you to plug in 16 for all those x's. Do we get our value? How many 100-year-olds do we have? $185.607. Okay, so there's 185 100-year-olds. Thousands. Good. Be careful. Okay, you got to go back to the data table. What do your numbers mean? Okay, so it's not just 185 100-year-olds. That's thousands. So we got to make sure we throw in that word afterwards. All right. Let's finish things off with number 5. Predict when there will be 80,000 100-year-old Americans. How can we use that really, really good quadratic equation to predict that information? Say it louder. I heard it. Set it equal to what?
The 80,000.
All right, so we're going to take that quadratic equation and set it equal to 80,000? Just 80, right. 80. All right, so this one's a little bit more complicated than the linear one. Linear equations just have one x, easy to solve for by hand. This one happens to have two x's in it, so we're going to utilize graphing calculator. You could use the quadratic formula, by the way. We'll be talking about that later this week. I'm seeing some heads going this way, but they will be going this way. Okay? We could use the quadratic formula, but we're going to use our calculator. So, in your y equals, you should already have the parabola in there. Let's go ahead and type in 80. And we'll graph that line. What are we looking for? Where they intersect. Good. All right, intersection. What are our buttons? Second, trace. That's kind of our go-to menu when we're graphing. Choose option 5. Second, trace. Okay, the blue button and then trace. Option 5. Move the cursor or spider to where you think the intersection is.